Very good morning, students. For this lecturing video session, I am going to cover the introduction of special curves. I already taught you the first chapter of first unit, which was conic section or conic curves. The second chapter of first unit is special curves. See, under special curve, that means special curve further classified into two: cycloidal curves and involute. Cycloidal curves further classified into three: cycloids, epicycloids and hypocycloids. For this session, I am going to give brief introduction about the cycloidal curves. In the next video, I will give the brief introduction about involutes. Right. So, first of the cycloidal curves, the first division of cycloidal curve, which is cycloids. What do you mean by cycloid? A cycloid is a curve traced by a point on the circumference of the circle which rolls along the straight line without slipping. So, assume a disc which is nothing but the rolling circle or generating circle. This can be named as rolling circle or generating circle right. Its center termed as C. What would be the circumference length of the circle? It could be the circumference length of the circle is nothing but pi d. When the rolling circle completes one full revolution, it traces numerous points on the space. So, I am going to trace that point. So, by tracing those points, we will get the curve which is nothing but the cycloids. Right. So, this is the rolling circle, which always assume that it always rotates in the clockwise direction. Right. This is the point which is touching on the horizontal surface or on the straight line. And pi d, there is a distance to cover one full revolution or one convolution of the rolling circle. When this particular rolling circle starts rolling on the straight line, right, this is the point which is now touching on the horizontal table or the straight line. Right. When it starts rotating, that means this point, when it starts rotating, this point comes here, and when further it rotates, it leaves a trace to complete here, right. So, the circle is here. When it completes one full revolution, the position could be here. This is the starting point. When it starts rotating, it leaves trace. Now, I am just plotting all the traces. So, this curve is nothing but the cycloids. This is called cycloid. Right. The distance, that is the circumferential distance, which is nothing but pi d. This is nothing but pi d. Remember, this rolling circle always rotates in the clockwise direction, and this is nothing but the directing line or baseline or straight line. So, on which the rolling circle rolls without slipping. Right. Now, I am going to give a brief introduction about epicycloids. See, as far as cycloid is concerned, only one circle, that is rolling circle or generating circle, which rolls on the horizontal table or on the flat surface or on the straight line. See, as far as epicycloid is concerned, the definition of epicycloid is nothing but it is a curve traced by a point on the circumference of the circle without slipping on the outer surface of the another circle. So assume a circle and its center is termed as O. So this circle is nothing but the base circle or directing circle. This is nothing but base circle or directing circle. Directing circle. Understood? So now over this base circle or directing circle, one circle is going to roll over it. The circle name is nothing but rolling circle or the generating circle. Right? This is nothing but rolling circle or generating circle. Generating circle. And its center can be termed as C. And the contact point of both rolling circle and directing circle termed as P. See, as far as cycloid is concerned, the rolling circle started rotating in the clockwise direction. Similarly, for epicycloid also, the rolling circle tends to rotate in the clockwise direction. When the rolling circle starts rotating over this, that means the circumference of the other circle, it leaves the traces, isn't it? So when I plot all the points, I could get a curve which is nothing but the epicycloid. So when it starts rotating, it could trace some point, isn't it? It could trace some points. By plotting these points, I could get a curve which is nothing but the epicycloid curve. Right? This is the rolling circle when it tends to rotate in the clockwise direction to complete one revolution over the base circle or the directing circle. Look at this sector. So to complete one full revolution, the sector which would have covered over the base circle, which is termed as theta. Right? So what would be the formula for theta? Theta equal to r by small r by capital R into 360 degree. The small r is the radius of the rolling circle and capital R is the radius of directing circle or base circle. This is nothing but the radius of the rolling circle. And the capital R is nothing but the radius of the base circle or the directing circle. Understood? Let me just repeat. So epicycloid is nothing but rolling circle rolls over the circumference of the other circle, which is nothing but the base circle or the directing circle. Always the rolling circle rotates in the clockwise direction. When it tends rotating on clockwise direction, it leaves some traces in the space. By plotting those points, I could get a curve which is nothing but the epicycloid. To complete one full revolution or one convolution, it would have made a sector, right? So, which is nothing but theta. Theta is nothing but r by r into 360. Small r is the radius of the rolling circle and capital R is the radius of the base circle or directing circle. So, the example of the engineering applications of the cycloidal curves are gear. So, that is a gear, isn't it? Fine. So, let me, since I have completed the cycloids and epicycloids, the one which is left out is hypocycloids, right? So, cycloid is nothing but when a rolling circle, that is circle which rolls on the horizontal line or the straight line to complete one full revolution. See, epicycloid, the rolling circle rolls over another circle, right? So, and what about hypocycloid? The hypocycloid, see, as far as hypocycloid is concerned, the definition of hypocycloid is the curve traced by a point on the circumference of the circle without slipping, right, on inside of another circle, right? Right. So, now, so this is the directing circle or the base circle. Is center can be denoted as O, right? See, as far as hypocycloid is concerned, this rolling circle rolls inside of the base circle or the directing circle. So, assume this is the rolling circle or base circle. Sorry, this is rolling circle or the generating circle, right? This bigger one is nothing but the base circle or directing circle. Directing circle. And the smaller circle, which is nothing but the rolling circle or the generating circle, right? Its center can be denoted as C. The contact point can be denoted as P. See, for cycloid and the epicycloid, the rolling circle start rotating in the clockwise direction, whereas in hypocycloid, the rolling circle rolls in the counterclockwise, which is nothing but the anti-clockwise direction. When it start rotating in the anti-clockwise direction, it leaves some traces. It leaves some traces. To complete one full revolution or one full convolution of the rolling circle, it leaves some traces and it completes here, right? So, now the rolling circle is somewhere here to complete the one full revolution. When I plot the traces, I could get a curve, right? So, this curve is nothing but the hypocycloid. Hypocycloid. Understood? So, the sector which would be traveled to complete one full revolution of the rolling circle is nothing but theta, right? Theta, the formula of theta is nothing but r by r into 360 degree. Small r is nothing but the radius of the rolling circle, radius of the rolling circle, and the capital R, the radius of base circle or the directing circle. Remember this? So, let me just give a quick review over this. As far as cycloid is concerned, the cycloid rotates on the clockwise direction, which always rolls on the flat surface, that is in the horizontal line or the horizontal table or a flat surface. To complete one revolution, it traces some points, right? So by plotting that, you will get a curve which is nothing but cycloid. See, as far as hypocycloid is concerned, the rolling circle rolls over the another circle which is nothing but the base circle or the directing circle. To complete one full revolution, the rolling circle rotates in the clockwise direction and leaves the some traces over it, and by plotting that, we will get a curve which is nothing but the epicycloid. See, as far as hypocycloid is concerned, the rolling circle rolls inside another circle, that is base circle. The rolling circle rolls inside the base circle or the directing circle, and here the rolling circle rotates in the anti-clockwise, that is counterclockwise direction. To complete one convolution, it traces some point, that means it leaves some points. So by tracing that, you will get a curve which is nothing but the hypocycloid. This is the segment of the base circle to complete one full revolution of the rolling circle, that is termed as theta. To find the theta value, the formula is r by r into 360. R is nothing but the radius of rolling circle, capital R is the radius of the base circle. So in the upcoming videos, I will come up with few problems for your better understanding how to construct the cycloidal curves. Thank you.